Good morning. I'll plan on doing the Leetcode contest from last Saturday, contest 284 virtually. So here we go. Open these guys up here. And here we go. Find K distance indices in array. Two integers key and K. K distance index I, for which there exists one index J, such that the absolute difference between I and J is less than or equal to K. And num sub J equals key. K equals 1. Num sub 2 equals the key. Num sub 5 equals the key. Okay. So how many are less than K distance away from those two keys? For index 0, it's greater than K. For index 1, 1 minus 2 is less than or equal to K. Zero, 1, 2, 3. Index 1, or 0, 1, 2, 3. 0, 1, 2, 3, 4. Okay, so it looks like we should be able to pre-process the array. Our target. Okay. Since n equals 1,000, even a naive algorithm will be AC, right? A quadratic solution. Oops. But what we can do is pre-processing to track nearest key index to the left and to the right. And see if those indexes, if they exist. Key is an integer. Okay, key has to exist. Okay. Yeah, okay. One has to exist per the problem statement. Check if those, let's see, check if those indices are less than or equal to K away. If so, add index I onto the list to be returned. Okay, so that's the game plan. Let's start the implementation, see what happens here. 8:07 a.m. start implementation for IX and A dot with index. Our answer will be a mutable list with integers. Return answer. Oop, there we go. Okay, so let's do some pre-processing. N equals A dot size. Var L equals int array in. Put them all to 0. So these are our pre-processed indices from left to right and right to left, looking for the target T. If X equals the target, then L sub I equals 0, R sub I equals 0. Oops. Otherwise, do this. Let's do this instead. Let's do for I in 1 until n. If a sub 0 equals a target, then L sub 0 equals 0. So actually, let's initialize this to infinity then in this case. Infinity is an integer which equals 29 plus 7.2int. Okay, so these are initialized to infinity, set to 0 in that case, and then if n minus 1 is target, then R sub n minus 1 is that guy. Okay, this is left. So then L sub I equals if A sub I equals T, 0, otherwise 1 plus L sub I minus 1 for I in n minus 2 down to 0, R sub I. Let's do this. Let's just move these onto single lines. R sub I equals if A sub I equals T, 0, otherwise 1 plus R sub I plus 1. Okay. For I in 0 until n, if L sub I less than or equal to k, or R sub I less than or equal to k, then ands dot add I. Okay, I think that would work. 807 to 812. 812, just about 5 minutes for implementation. 5 minutes. Okay, compile error in. Doesn't know what that is. 1, 2, 3, 4, 5, 6, which is correct, and then 0, 1, 3, 2, 4 for the other one. That looks good. Okay. You see. Okay, so yeah, it's a pretty decent solution. Let's write it in JavaScript and Python 3 and C++ here real quick. 812. ATK. All right. Oops. Let's do this. N equals a dot length. Then for let's L equals array sub n dot fill infinity. R is equal to the same thing. So pre-populate these guys for let I equals 0, I is less than n. Okay, so set this guy to 1. If A sub 0 equals the target, then L sub 0 equals 0. If A sub n minus 1 is equal to target, then R sub n minus 1 equals 0. And L sub I equals A sub I equals the target, 0. Otherwise, 1 plus L sub I minus 1. And then for I equals minus 2 down to 0. R sub I equals A sub I t 0. Otherwise, 1 plus sub I plus 1. All right, let's create our answer, populate it, and return it. Return the answer. Actually, let's do this. Instead of the answer, we can just filter the array and do this functionally. So let's do this. Array sub in dot keys dot filter it L sub it less than equal to k, or R sub it equal to k. We'll just do I, right? I is okay. All right. Yep. That. Oh, no, that's not right. Missing the 1. By R sub I. Looks right. Let me print these real quick and see what's going on. Where's the 1? L sub I. Hold on. Put these on different. To the left. To the left. To the left. It's 0. To the left is 1. To the left is 2. 0. To the left is 1. Okay, that looks right. But to the right is never correct. R sub I. Oh, double equal there. Like, what's going on? Okay, that looks legit. Okay, yay. And I might as well update Kotlin to do the same thing, right? I don't need the answer explicitly to be formulated. I can just create it functionally. Turn int array sub n sub it dot filter L sub it less than equal to k, or R sub it less than equal to k dot to list. Okay, that should be legit. Looks good. Okay, that's cool. Let's do this in Python 3. Target. Okay. N equals length of A. L equals array of infinity. And same thing for R. And then for L sub 0 equals 0 if A sub 0 is T. Otherwise, float of infinity, R sub n minus 1 equals 0 if A sub n minus 1 is the target. Otherwise, it is also an infinity. Actually, let's do this. And goes float. Oop. There we go. A little bit less verbose. Right, so these are just sentinel placeholders. Okay, and then for I in range 1 to n, non-inclusive. Then L sub I equals 0 if A sub I is the target. Otherwise, equals L sub I minus 1 plus 1. And then the same thing for the right, for I in range n minus 2 down to -1 non-inclusive, R sub I 0 if A sub I is the target. Otherwise, 1 plus R sub I plus 1. Then we can return the array of I for I in range n if L sub I is less than or equal to K, or R sub I is less than or equal to K. Alrighty, looks good. Yay. And C++ is next. Vector int, and I don't know if I should try this one in Rust or not. Maybe I'll give it a shot too after this. Let's do this guy, do Rust next, and move on to the second question. Okay, so VIL n equals a dot size n build up with infinity. Math equals 189 plus 7 r for okay, so populate these guys. If a sub 0 equals the target, then L sub 0 equals 0, or auto I is 1 until n non-inclusive. A sub I, let's see, L sub I equals, this is the target, then it's 0. Otherwise, it's 1 plus L sub I minus 1. Do the same thing for right. Minus 2 down to 0. R sub I target, then it's 0. Otherwise, it's 1 plus R sub I plus 1. Then we can return an array of all those values. Okay, so vi and n return the answer, auto I 0 to n non-inclusive. If L sub I is less than or equal to K, or R sub I is less than or equal to K, and is that push back I? There we go. Whoa, a whole bunch of zeros. What? Oh, and sub I equals that. Oh wait, yeah, it's, I don't want to have an answer like this. Yeah, we do want to populate it, right? So, there we go. That looks better. Okay, looks good. Wrong answer. Uh-oh. I'll put it as 1, expected 0, 1. R sub, oh, I didn't populate R. Okay, so if a sub n minus 1 is the target, then R sub n minus 1 equals 0. Okay, and VI and just populate it up there. Should be good. Okay, cool. Let's do this Rust real quick. Type VI, spec I32. TK. VI and oops, let mute ands equals vector. Turn the answer. Okay, let n equal a dot length. Let mutable L equals vector of length n populated with the value infinity. Let n equal 29 plus 7. Is it parse I32? Something like that. Now let's just do this. 1, 1, 2, 3, 4, 5, 6, 7. Right, there we go. Let mutable R as a vector as well. Absolute infinity of length n. If a sub 0 is equal to the target, then L sub 0 equals 0. If a sub n minus 1 is equal to the target, then R sub n minus 1 is equal to 0. For I in 1 until n non-inclusive, L sub I equals a sub I target 0, otherwise 1 plus L sub I minus 1. And for I in n minus 2 down to 0. I don't know if this works or not. Let's see what happens. R sub I equals a sub I t 1 plus R sub I plus 1. Okay, and then let's do this. Return 0 to n non-inclusive which is a range dot filter it on L sub it less than or equal to k or R sub it less than or equal to k. Okay, something like that. Let's see what happens. Probably not going to compile, so I have to fix it up. Expected one of wonder Rust ternary operator. Oh, it doesn't have that. Okay. If that is true, then this guy. Otherwise, this guy. If that guy. Otherwise, this guy. Consider removing this semicolon. Oh, yeah, that's right. Slice indices are of type usize or ranges of usize. What the heck does that mean? Dot collect. Slice index integer not implemented for ampersand usize. Cannot be indexed by usize. What? Let's just return an empty vector and then let's actually print what's going on here. Print, see if this is actually correct. Debug output for L and R. Expected, oops, it's the Elvis operator, but it's backwards. right. Right is not correct though. Let's do this for right. In 0 to n minus 1, non-inclusive dot. I wonder if we can reverse this. Rest reverse range. May collect iter or dot rev. Okay, cool. Dot rev. Okay, that looks right. Now just gotta get this return statement working. I wonder if we can map it before we filter it. Or dot map. It as I32. Alt of it, R sub it cannot be indexed by I32. Slice indices are type usize or ranges of usize. What the heck? What the heck does that mean? Rest map range to vector. I don't know. How can a range be used in the back? Dot iter dot. Oh, do I need an iteration? Dot iter? Filter. Dot collect. Maybe that looks right. Iter not found for that. What? Need a, like a vector of these things? Like map. Collect into vector. Oh, I see. Okay. Don't need to iterator unless if I collect it. These guys do mapping it. That. Whoa. Oops. Cannot be indexed by I32. What? Size. Filter. Size. What the heck? Yeah, still having a hard time here with Rust, obviously. Man, found signature of FNU size. Expected signature for R prime has like a different lifetime. Collect iter? I don't know. Collect. Collect to vector of integers. Size. view size, view size. I don't know what I'm doing here. So yeah, just oops, I'll this here later. Just trying stuff, throwing things up on the fence, whatever. Here, let's just post what we got so far and then move on. This is taking too long. Solutions. C++. Python 3. JavaScript. Oops. JavaScript. Fat fingered the caps lock there. Okay. Kotlin. Oh. Go. Python 3. JavaScript. Kotlin. Yeah, I suppose we could do this the hard way, the verbose way in Rust until I figure out how to do Rust a little bit better. Let's do this actually. Yeah, so let mute and equal vector populate with 0 length n, and then for I in 0 until n non-inclusive. If a sub I equals t, oops, L sub I is less than or equal to k, or R sub I is less than or equal to k, then we'll add on to the answer. And dot push I. Turn the answer. Okay. No way. Expected I32 found use size. Okay. As I32. Okay. I think that's fine. Okay. There's rest. Good enough. Let's see how much time we have left. That took half an hour. Oh, dang. Key distant indexes and array. Okay. Start number 2, 8:37. 8:37 a.m. Okay, let's read this, see what happens. 0 index grid, some artifacts behind it. Enter in. Rectangles, okay, so row, column for top left, bottom right, okay. Dig. Turn the number of artifacts you can extract. Test cases and guarantees so that no two artifacts overlap. Each artifact only covers at most 4 cells. Entries of dig are unique. Okay, so dig 0, 0. Different colors represent different artifacts. Executed cells are labeled with D, 0, 0, and 0, 1. There's one artifact that can be extracted, namely the red artifact. Blue artifact has 1 part in cell 1, 1. Blue artifact, which remains uncovered, so we cannot extract it. Thus we return 1. Artifacts, so there's 0, 0, 0, 0. Okay, so there's one artifact here, and there's one artifact at 0, 1, 1, 1. Okay. There's red artifact here, blue artifact there. We dig there, we get one. We dig here, we don't get the whole thing, so it doesn't count. Okay, so only if we dig and we find the entire artifact, we count it. Okay, 0, 0. There's 2 artifacts. Okay, so dig here, dig there, dig there. Okay, got both. Okay, so as long as we dig and capture the entire artifact, then that counts. Okay, so what's the game plan then? Game plan. So for each artifact, use the index as a key to a map of the array A. Use the index I as the key to the map M, and then create a set of all pairs for each cell ij of the artifact. Okay. And process dig array wait, we don't want that. We want the map to be, say, so use the cell ij as a key to the map. And then use a counter array to, which is incremented for each cell of the artifact. Oh no, the map is the counter array, right? Used as a count. No. Map. So the key is each cell, which maps to the index. Value is the index, and then the counter array is incremented for each cell of the artifact per the index mapping. Yeah, and then when we process the dig array, basically go use the map M to find the index of the cell ij, and then decrement counter array for index. If it is 0, then increment count to be returned by 1. Okay, so that's good. Answer is 0. Turn ends. Okay, so these are artifacts in, and then dig. Just leave it like that. M is a mutable map of string to integer, and then our count equals int array of n 0. Okay, and then for each artifact, IJUV, top left, bottom right. I is less than or equal to u. Go through each ith row. With index. I wonder if this will work, destructuring it like that. M sub k equals, or wait, hold on, M sub equals k. Just call this index, and then k equals j, while k is less than or equal to b. That's the kth column. So cell equals $i, $k. I throw kth column. M sub cell equals index. This can do M sub this guy. Okay, and then count of the index is incremented by 1. Or dig has an ij. Dig. Index equals M sub $i, $j. Actually, let's do this. Key equals $i, $j. If M doesn't contain the key, we'll continue. Otherwise, index is M sub k. If count index is equal to 0, then increment the count by 1. Okay, let's see what happens here. Expecting a name, index, this and that. Okay, I can't destructure it this way, so I do need to index and then value. IJUV is value. And reference K, key. Key. Okay, so that's 1, that looks good. There's 2, okay. Oh no, index out of bounds, uh-oh. Index out of bounds exception. 0 indexed. Five, 0, 1, 2, 3, 4. What? What is n then? Oh, okay. N is not the length of this thing. Can't use a dot size. What the hell use is n? It's n by n grid, but it has nothing to do with the artifacts. Oops. Okay, well, n's not used. Okay, yeah, so note to Leetcode FU for the n, it is not helpful. Please write a better function argument list next time. 8:51, about 14 minutes. Yeah, it's a fairly decent solution. Right, so stick each cell in the map index, increment the count of the index, and then, yeah, all right. Yeah, that works. Let's do this in JavaScript, Python 3, and C++. And then move on. At this pace, I'm not going to get to that fourth question, but let's see what happens. N equals a dot length. This is the useful n. Array sub n dot fill 0. Turn answer. Answer will basically be a count in itself. Okay, so for the index of A, oops, hold on. I don't want to do that. I want to go for each artifact of A. So for, yeah, let I equal 0, call it index n. IJUV equals index. I is less than or equal to U. K equals J, while K is less than or equal to B. M, let key equals tick. I row kth column. M dot set key 1 plus. That gets key or 0. And then also increment the count of the index. Counts of index incremented by 1. Or let I ij of dig. That key equals ith row, jth column, m dot set key -1 key. Or 0 if m dot get key is equal to 0. Look at the answer. Index. That does not look right. Okay, so key, actually I need to get index, right? Let index equals, yeah, this is not right. M, hold on. If not m dot as key, we'll continue. Otherwise, let's do this. Let index equals m dot get key. If I count at the index 0, then we'll increment the answer. Right, okay, that looks better. No, that's not quite right. Count before and after. Something's not quite right. One cell, two cells, one cell, 0 cell. This is not right. This should be m dot set key index, and then increment the count. I was getting that confused. Okay, that looks good. And submit. Looks good. 8:52, 8:57, 5 minutes. Okay. Python 3. N is useless. FU Leetcode. Okay, M is that map. Answer 0. Will increment and return 4. Index value and enumerate a ij uv equals the value. While I is less than or equal to u, I plus equals 1, j, while k is less than or equal to b, k plus equals 1, and then the key is formatted string I row kth column, and then m sub key equals index. And then we want to count n equals the length of a count equals an array of 0 for all n, and count sub index plus equals 1, and go through dig for I, j, and dig. Key is I, j. If key not in the map, then we'll continue. Otherwise, index equals m sub key. Then if count sub index minus equals 1, if not count sub index equals 1. Looks good. Good, okay. That thing. Vector of integers. Key. Answer. Okay, and then for auto each. We want to call this thing a rectangle artifact. Artifact, each artifact in an array. Artifact 0, artifact 1, auto UV, sub 2, A sub 3. While I is less than or equal to U, K equals J, while K is less than or equal to B, K, and string stream, put into that ith row, kth column, key equals that guy. Then we need to use a map. Use a map, it's another map, string, int. So that'll map the cell to the index. And then count for each of those indexes. M sub key equals index. Index listen n index m sub key equals index plus count of that index. Okay, and then go through dig for candidate to dig. I don't know, just call this a pair. IJ equals tie, pair sub 0, pair sub 1. Now let's do this. Let's create a key. Key equals auto I, auto J, string, stream, I, J. Okay. Let's just call this guy hash. We'll call key equals hash IK. Key equals hash IJ. If m.find key equals m.end, continue. Otherwise, if count of that index zero, will increment the answer. Tie A sub index sub 0. Okay, looks good. Accepted. Holy cow, this thing's huge. All right, whatever. That works. Few solutions. Oh, you know what? Hold on, I want to go back here. I don't think I didn't even write a description on this one. Hold on. Go back to Q1, add a little description at least. It's pretty straightforward, but whatever. Let's see, hold on. Pre-process the input array A from left to right and from right to left. To calculate the nearest jth index with target value t. Then return the filtered indices 0 dot dot n minus 1. Where so you return the filtered indices 0 to n minus 1. Like left and right is less than or equal to k, right? We preprocess the input array from left to right, from right to left, and calculate the nearest jth index. Then return the filtered indices I equals per the problem statement. Right? I don't need to repeat the whole thing. All I indices less than or equal to k away from the nearest jth index. That's good enough, whatever. I mean, it's pretty straightforward, right? Preprocess left to right, right to left, and then filter that index array. Right. Okay, cool. Nice to have a little description though, right? Not purposely making this difficult, right? Okay. A few solutions, and then, yeah, so copy and paste these in here, and then move on to Q3. Add a description here real quick. So use a map M to associate each ij cell with the index of the artifact within the input array A. Then and keep track of the quantity of cells per artifact in the array. Check at the count. count. When digging, we decrement each ij cell and increment the count of the answer. I guess increment the answer count whenever the count of cells per artifact reaches 0. All right, Python 3, JavaScript, Kotlin, all right, Python 3, JavaScript, Kotlin. Okay, that's a decent solution. Use a map M to associate each IJ cell with the index of the artifact with the number array. Track count of cells per artifact. Yep, that looks good. Okay, and we have 22 minutes left for Q3. Okay. 22 minutes remaining in the contest. 9:12. Okay. Okay, and let's read the problem statement. See if we can get this done. Might be a clutch move to get 3. 0 indexed array nums pile. Topmost element of the pile. One move you can either. Pile's not empty, remove it. If there's one more removed elements, add any one of them back onto the pile. This element is okay. Okay. Return the maximum value of the topmost element of the pile after exactly k moves. This is not possible, just hang on empty pile after key moves returning 1. Okay, so one of the ways we can end with 5 on the top of the pile after 4 moves is as follows. Remove the topmost element 5, the pile becomes that. All right. Remove the topmost element 2, 2, and then add 5 back. Note that this is not the only way to end with 5. In the first move, our only option is to pop the topmost element from the pile. Okay. When k is odd, and the array is odd, does that cause a problem? Let's see. I characterize it and see if there's any patterns. 2, 3, 4, 5, 6. N equals 6. K equals 4. 1, 2, 3. And push that on back as the 4th. So we can take k minus 1 from the left and then push the largest value back, right? So consume k minus 1. The leftmost k minus 1 elements of A. I guess at some point we can simply push pop back and forth. Like if we had the 5, let's say we take it away. Take these 3 away, basically. Beware of corner cases. Yeah, this one's tricky with corner cases, right? We can consume all 4 and maybe that 5th one. 0, 1, 2, 3. The 5th one might be the biggest one. And so what are the use cases? See, 1, we take them all, right? Remove leftmost k minus 1 elements, and then push back the maximum of a sub 0.k minus 1 inclusive. There's the leftmost k minus 1 elements, and then have one that you can add back in. In this case, if k is equal to the length of the array, then there's nothing we can do, right? Oh no, if k equals 2 and nums is 2, we could still remove and then add back. So this is a special use case. Right, you have to remove it and then you're empty. K equals 1 and nums. Okay, so if a size is 1 and k is 1, then return -1. Otherwise, then what if The cardinality of A is less than K, right? K exceeds it. Let's say A equals 2, right? K equals 2. Remove 2 and add 2 back onto A. But if K equals 3, then what do we do? Remove A, add it back, and then remove again. Remove it again. Be empty. If A equals 1, 2, and then K equals 1, you can remove, it's fine. If K equals 2, here, remove, add, that's okay. Remove, remove. Okay, let's remove all K is in G, it's no good. So case 1 would be not applicable. A equals 1, 2, K equals 3, then what would happen? I could remove it, add it back, and remove it again. Remove 1, add 1, del 1, add 1, del 1. So that would return 2. So if K is odd, but then A is even, right, it's the same thing. 5, 7, 9, 11, all the same thing, right? So if it's 5 is delete 1, add 1, delete 1, add 1, delete 1. Still will return 2. Okay. Yes. In this case, this is just tricky and kind of irritating. Yeah, yeah, there's a lot of corner cases to consider. It's kind of a pain in the ass. All right, I'm gonna go to the fourth question. Minimum some subgraph with required paths. Select a graph that's weighted. Source 1, source 2, and destination. The minimum weight so good as possible to reach from both those via a set of edges of its graph. Source 1, source 2 is 0 and 1. Source 1 to destination 5. Okay. Shortest path from 1 shortest path to 5 is go this way or go that way. Wait, this one seems a lot more interesting, I'd say. Source 1 is 0, source 2 is 1, destination is 2, so you can't reach it. It seems like we could just do a linear algorithm for shortest path, right? We could do Bellman-Ford, or we can do Dijkstra. I have 8 minutes left. Pairwise distinct, right? Okay. 0 to n-1 for the weighted graph. Okay. Just do Dijkstra twice. We have edges. Let's call A, B, and C. DIJK, STRA, or single source shortest path from A to C and from B to C, right? Dijkstra will be our function, which will take a source and a destination. Source, destination. And then, well, we're given edges. So since we're giving the edges, it doesn't make sense to do Dijkstra. Actually, it makes way more sense to do Bellman-Ford and then put in the adjacency list, and we can do the shortest path faster algorithm. So basically, Bellman-Ford will try to relax all the edges n-1 times given n vertices. And shortest path faster, we'll use an adjacency list in order to only attempt to relax the candidate edges. So SPFA is a natural progression of Bellman-Ford. Anyhow, let's do this Bellman-Ford. And I think I can probably get this done. I have 6 minutes left, so it'll be super clutch. Let's see. I'm going to just focus on doing this here real quick. Okay. Distance to V exceeds the distance from U plus W. Right, basically, we're relaxing that edge. Dis of V equals dis of U plus W. Okay, and then return distance to T. Okay, and then return F sub source to the target plus F sub that source to the target. 12, is that right? No, uh-oh. Print dist. Let's see what happens here. What's going on? Okay, so source 0, distance to 0 is 0. The best distance to 1 is 3. 0 to 1. It's 3. Okay, that looks right. Distance to 4 then should be 8. 0, 1, 2, 3, 4. It's 7. 2. No, that doesn't look right. What the heck? 0 to 2 should be 2. 0, 1, 2, which is 2. 3. How could 4 be any less than 8? Going this way in the wrong direction? It is directional though, right? So 0 to 5. 0 to 5 for cos 6. There is no 5 to 4 though. Disconnect from the band, get the music going. Okay, so what's going on here? Just capture a picture of this guy. So 0 is our source. That's fine, that's where we start. 2 is 2. 1 is 3. 0, 1, 2, 3, and then 4 is 5. To 4. 0, 1, 2, oh, 3 is 5. 0, 3 is 5. Okay, so that is correct. 3 is 5. Oh, if 3 is 5, then that's how I get 7. Okay, so what the heck? The minimum weight is 7, and then source 1. What? Note that the subgraph awfully is the optimal answer. It's not possible to get a subgraph for less than weight satisfying all the constraints. It's the set of edges then? Two, 5, 7, and then 1, 5, 6. One, 0, 1, 2, 3, 4, 5. Destination is 5, and I can get there in 6, right? 6, 7. You think it'd be 13, isn't it? F sub AC. Hold on. F sub AC. Sub BC. 6 and 6. How do you get to from 0 to 0 to 5 is 6. Okay, that's 6. For some reason I was thinking the destination is 4. Okay, 0 to 5. Okay. 6 here. And then from 1 is 1 we go 5, 6. 0 goes to 2. No, just 0 goes straight to 5, isn't it? What the heck? 0, 6. Edges are 0, 5, okay. Oh, I see. Not quite as naive as I was thinking. So Bellman Ford would choose 6, but since 6 isn't overlapping with the optimal solution for the other traversal, then it costs more. Oh, okay. This is actually a cool problem, right? Okay, so Q3 kind of totally sucks. Corner cases. This one, Q4 seems cool. We'll plan to upsolve. Not as naive as I originally thought. So that does make it interesting. Okay, anyhow, yeah, the contest ended. Catch you next time. I'll upsolve that one. Bye.